And then the last thing I need to do is state domain and range in interval notation. So domain is not going to change. It goes from negative infinity to positive infinity. And the range is the same as the parent function, from 0 to infinity, because at 0 we have the asymptote. Okay. For the second example, we have a -5, but notice that this 5 is not it's not with x. So that means this is a vertical transformation. So all this is going to do is it's going to shift or translate the graph down 5 units. Okay. So then from the origin, go down 1, 2, 3, 4, and 5. So we go from this plus sign now. And before I start plotting the points, I'm going to sketch the asymptote, so that I have this to help me sketch the graph and sketch it in such a way that it doesn't touch the asymptote. It gets close to it, but it can't touch. Okay. So then, since there's nothing else, I can use the same table. So from here, if I go left 1, up 1/2. If I go no left to right, then up 1. If I go right 1, up 1 and 2, and then connect the points hugging the asymptote. The graph does hug the asymptote, but this is what graph looks like. And as you can see, is this same graph. It just got translated 5 units down. Okay, so let's see. Domain for this one. Domain is no different. Okay, I'll give you a hint here. Domain will never change, because this will continue going left. So it goes to negative infinity and continues going right. So it goes to positive infinity. The one that might change depending on this value is going to be the range. So the range, instead of going from 0 like this one, now it goes from -5. Okay, so at the bottom is going to approach -5, but then it's going to go up to infinity. So there is the graph, domain, range, and the transformation. Number 3. So there's a negative in front of the base. So that negative is going to make the graph, just like it does to every other graph, is going to make it reflect over the x-axis. Okay, which means I have to do this table, but then change the y values to negative, change the sign of the y values. So I'm going to copy that table first, and then we'll do the transformation, we'll do the graph. So this is the table for the parent function, x, y, -1, 0, 1. This is 1/2 for y, 1 for y, and 2 for y. But then there is a negative in front of that base. So all you have to do is change the sign of the y values. So then this becomes -1/2, this becomes -1, and this changes to -2. Then I am going to cross out the center column, so I won't use those y values for direction. Okay. So then this one, there is no plus or minus like here. There's -5, so that means we're going from the origin. So I'm going to sketch the asymptote. So now, since we're going from the origin, if I go left 1, down 1/2. If I go no left to right, then I need to go down 1. If I go right 1, down 1 and 2. And now when you connect the points, notice that this graph points down, doesn't point up, because of the reflection over the x-axis. So again, for domain and range, domain, this will continue going left and will continue going right. So the domain for this function is negative infinity and positive infinity. So that transformation didn't affect the domain. The range, however, in comparison to the parent function, this one goes now to negative infinity. So don't forget, range is always bottom to top. So at the bottom, or on the bottom, doesn't have one, but it goes to negative infinity. And then it approaches the asymptote, which is where y is 0, and gets close enough to it, but it can't touch that value. Okay? Okay, let's go to example number 4. So notice this one has a 3 in front of the base. Now, be careful with these. Whichever number has the exponent, that's the base. So this is the base. 2 is the base. This is just a value. We call this a, but I'll come back to that in another lesson. So the point is we have a 3 in front of the base. So that means the y values are going to get multiplied by 3. So this has a vertical stretch by 3. And then that -7 is going to make the graph go down. It's going to go down, or translate it down 7 units. Okay, so from the origin, I'm going down 1, 2, 3, 4, 5, 6, and 7. So we're going from this point out. So I'm going to sketch the asymptote before I do anything else. So always do the transformation and then sketch the asymptote. From here, I need to change the table because I have a 3 in front of the base. So I'm going to copy that table from the parent function. xy, -1, 0, 1. Y is 1/2 when x is -1, y is 1 when x is 0, and y is 2 when x is 1. Now take the y values and multiply them by that value of 3. So 3 times the y values. 3 times 1/2, I'm going to write this in decimal form. So that's the same as 3/2, which is 1.5. 3 times 1 is 3, and 3 times 2 is 6. Okay. Then I'm crossing out that column. So then from this point, if I go left 1, I'm going up 1.5. So there is that point. If I go no left or right, then I need to go up 3. So that means from here, go up 1, 2, and 3. If I go right 1, then up 6. So right 1, up 1, 2, 3, 4, 5, and 6. And as you can see, this graph grows faster because of that value of 3. And this is what the graph looks like. Now again, domain does not get affected. So domain is still -infinity to +infinity. The range, however, is going from -7 to infinity. So the range, -7, comma, infinity. Number 5. Number 5 has a reflection across or over the x-axis. It's going to go to the right 1 and then up 3. So let me do this transformation first. Right 1, up 1, 2, and 3. So we go from this plus sign. So what I'm going to do once I get this plus sign is I'm going to sketch or draw the asymptote. So the asymptote will be right there. Okay, so again, what I'm going to do is with this one here, I am looking at this table because it's going to be the same thing. There is not, the value of A is 1, so all I have to do is go left 1, down 1/2. But now it's going to be from here. Okay, so if I go left 1, down 1/2. If I go no left or right, then I go down 1. So that's the second point here. And if I go right 1, up, I'm wrong here, aren't I? Yep, I'm going to cut myself. Okay, so from here now, if I go left 1, down 1/2. If I go no left or right, then down 1. If I go right 1, down 1, 2, 3, 4, 5, and how many am I supposed to go down? I'm just checking to see if you're paying attention here. Down 2, right? So this is 1 and 2. Okay, so then I'm going to connect the points, and this is what the graph looks like for this function. So let's go to example number 6. This has a -1, and that 1/4 is going to shrink the graph. Okay, so the transformations are, it's going to have a vertical shrink by 1/4, and then that -1 is going to translate the graph or slide it down 1 unit. So down 1. Okay, so let me do this transformation. So down 1 from here. So this is where we're going from, and then sketch the asymptote. Now, for this one, I do need to change the parent function table because I need to multiply the y values by 1/4. So the original table for the parent function, -1, 0, 1, 1/2, 1, and 2. Now, let's multiply the y values by 1/4. So 1/4 of the y values. 1/4 times 1/2 is 1/8. 1/4 times 1, 1/4. 1/4 times 2, 1/2. Then I'm crossing out that column. Okay. So now if I go left 1, this is not going to be noticeable. So if I go left 1, then up 1/8. So I'm just going to put it right on top of the asymptote, but right there. If I say a 0 for x, or meaning I don't go left to right from the origin of the graph, then I go up 1/4. So this is maybe about right there. It's barely noticeable, but a little bit higher than the previous point. And if I go right 1, up 1/2, so this one is more noticeable. And then when you connect the points, this graph is growing very slowly. Okay, so it's not going to be like the others, but it looks like this. All right, domain. Again, domain doesn't change in comparison to the parent. Negative infinity, positive infinity. The range, however, this is the one that gets affected, now goes from -1. So the lowest it goes is -1, actually approaches -1, and then it goes to infinity. Okay. Yes, I forgot to do domain and range number 5. So let's see. Domain. Domain is always for any exponential, negative infinity to positive infinity. And the range, this one goes from 3, it goes down. So that means negative infinity as it goes down, but then it approaches 3, but it doesn't get to 3. Okay? So let's go down to the next part. This one is asking us to write an exponential function matching its description. So notice this is base 5, so b is 5. And it's stretched vertically by a factor of 7. Okay, so let's start with the function here. So there is a 7, and the base is 5. So in parentheses, I'm going to put in a 5, and then to the x, then I'm going to leave some space here. By a factor of 7, translated 8 units down, so -8. And then let's see what else. Reflected over the x-axis, so that means there's a negative in front of the 7. Okay, and there is no left to right, so that means we can leave the x by itself in the exponent. All right, 7b. So I know it's going to be y equals. The parent function now, the base is 3, is stretched vertically by a factor of 12. So this has a 12 in front of it. Okay, in parentheses, the base is 3, so 3 to the power of x. Again, I'm going to close the parentheses, but I'm going to leave some space in case I need to add or subtract something to the exponent. And then, let's see, translated 10 units up. So that means outside of the parentheses, plus 10. And then translated 5 units to the right. So that means x minus 5 is the exponent of this exponential function. Okay, last part of the lesson. Without graphing, describe how the graphs of the following functions are related to the graph of y equals 10 to the power of x. So this is base 10. So this one here, I know you can't see it, but it's in your paper. This is x minus 11. So that minus 11 is going to make the graph go to the right 11 units, and this plus 2 makes the graph go up 2 units. Okay, so those are the only 2 transformations for number 8. Number 9 has a negative in front of it, and then the base is 10, so this means it's going to be a vertical stretch. So first, let's do the negative. So that's going to make the graph reflect over the x-axis. Okay, so that's the negative, and the 2 creates a vertical stretch by 2. Okay, and that's all for this lesson.